Hi guys. So today I want you to make a kind of summary poster or summary sheet about the points of concurrency that we've looked at. So there's 4 of them. There's perpendicular bisector, there's an angle bisector, median, and an altitude. So sorry, those are the special triangle segments, and then they meet at a different points. So what I'm going to show for you is I'm going to show you how you can take triangles at your house and create those 4 special segments. And you're going to create them on each of your angles, and then you're going to find where they intersect. Where those special segments intersect for each angle or each piece of the triangle will be the circumcenter, the incenter, the orthocenter, and the centroid. So the first one that I want you to do is perpendicular bisector. All of these meet at the circumcenter. So the perpendicular bisector, you're going to take a triangle, and I chose a different color so when I put on a poster it's easier to see the triangle, but I understand that you don't have different things at home, so whatever you need to do is fine. Perpendicular bisector, I'm going to take one side of the triangle and I'm going to fold it in half because this needs to bisect my side of the triangle. So if you notice, I'm lining it up, I'm folding it so there's no overlap on either side. This allows me to find the midpoint, and I'm just going to crease it just at the bottom. And then if I pull the triangle out, I now have the midpoint. So right here, I'm going to mark this. This is the midpoint of that side. So I made a small little mark. I know the midpoint of that side, and I need it to be perpendicular. So all you have to do is take something that's straight. So I just have like this post-it thing. And I'm going to hold that to my midpoint, and I'm going to make sure that it hits at 90 degrees. So what you can do is take the edge and line it up with the midpoint. So like I'm holding mine, you can hardly see this, I'm holding mine on a table, so I know it's meeting at 90 degrees. And then I'm going to draw along that. And so here is my best attempt. My first one's funny. My best attempt at a 90 degree line that bisects this side. Now I'm going to do that 3 times. I'm going to do it on this side, then I'm going to do it on this side, then I'm going to do it on this side, and then I need to find where they intersect, and where they intersect is called the circumcenter. This is the first thing that will go on your poster. That's perpendicular bisector. Okay, angle bisector is a little trickier. If you have a protractor, you can actually measure these angles and cut them in half, but I'm assuming most of you don't have a protractor, so what you need to do is some kind of silly folding. What you have to do is be really careful, but you're going to take your triangle and fold it as best you can in half so that it bisects the angle. And I understand that this is really tricky to do. But when you fold it in half, and you can crease it, so here's mine. I tried my very best, and you can see that there's no overlap on either side, but it doesn't line up perfectly at the bottom. That's okay. And I can undo it, and I'm going to darken this line so you can see it. But here's my angle bisector, and I found that just by folding that triangle in half. And I'm going to do that on each of these little angles, and where they intersect is called the incenter. Notice I'm following the 2 sides of the triangle. I'm lining up, I'm matching up because that's how they will bisect. And so here's my other one. And then you're going to do that on each side to form the incenter. The next one is the median, and the median is pretty straightforward. The median meets at the midpoint of the other side. So all you have to do, remember to find the median, or the midpoint, you take the 2 corners of the triangle and you hold them together and you fold it so that the sides line up, so there's no overlap here on either side. And I'm just going to put a quick crease at the bottom, and I can pull it out, and there is my midpoint. I'm going to put a mark there, and then a median goes from the midpoint to a vertex, so I'm just going to take a straight edge and go from the median to the vertex. So there's my first one. Notice it doesn't necessarily go on this line that we formed that's the perpendicular bisector, that crease. So I'm going to do that 3 times, and where they intersect is called the centroid. That's the one that has the 2/3. It cuts in 2/3 and 1/3. And then the last one is called the altitude. The altitude is the height of a triangle. And so all it is the point. It starts at the vertex and comes down and meets this triangle at 90 degrees. So it's possible that you have a triangle that you made where the altitude would be outside of the triangle. If that's the case, just draw it, like glue your triangle onto a piece of paper and then draw the altitude on the outside. That's fine. So all I'm going to do is take a straight edge, and I'm going to have to, my triangle's too big for my straight edge. What I'm going to do is take a straight edge, and you can kind of see this how I'm doing it on the table, but I'm just going to make my straight edge, I'm going to kind of run it until it hits the vertex of my triangle. So this would be too far, and this would be just perfect. And so now I have a line, if I were to trace this line, that would meet the vertex and the other side of the triangle at 90 degrees. So then I would just trace this line, and that would be the altitude. And I would do that for each of the sides of my triangle. And then obviously my straight edge is a little too short, so I would have to get a different one. But I would do that 3 times, and where they would meet is the orthocenter. And then once you have all of your triangles, you can glue them onto a piece of paper or tape them on, and you're making a summary sheet. So somebody who hasn't been in class could quickly say, okay, this is what a median is. It is the point that goes from the vertex to the midpoint. And they all intersect at a point called the centroid, and then you would explain to them what's significant about the centroid. The centroid meets, it breaks it up into thirds. 2/3 is the distance from the vertex to the centroid, and then 1/3 to the side. And you do that for each of your 4 segments and points of concurrency. The only one that's kind of funny is the altitude. There's not much going on, but it does meet at the orthocenter. So that's your assignment for today, and I am excited to see you guys soon. I hope you have a great weekend. Thanks.